So, question 5. PQR is a triangle with point P 34 and Q 9 minus 2. Shown a diagram here. Find the equation of L1. Find the equation of L1, which is the perpendicular bisector of PQ. So, perpendicular bisector. So that means it's going to be halfway between. It's going to cut halfway between this point PQ, and it's going to have a gradient that it runs perpendicular to it. So let's start off. So we're going to find the midpoint, and I'm going to get the coordinates 3, 4, and 9 minus 2. So our midpoint is just going to be 3 plus 9 over 2, and 4 minus or plus minus 2 over 2, which is equal to 12 over 2, which is equal to 2 over 2, which is equal to 6 and 1. Alright, so that's our midpoint there. Okay, so next thing we're going to need to do is work out the gradient of this line here, and then find out the perpendicular gradient of that line. Okay, so we need to go M, P, Q, so which is just y2 minus y1 all over x2 minus x1. So you can even label it here to make it simple. x2 y2, so that's going to be minus 2 minus 4 all over x2, which is 9 minus 3, which is equal to negative 6 over 6, is equal to negative 1. And we know that for perpendicular gradients times m2, we also have this relationship of negative 1. So what we're going to have to do here is take the 1 over this and reverse the sign. 1 over 1 is 1, and negative in opposite of negative 1 is just 1. So that's really good. So our gradient of L1 is just equal to 1. So that makes life pretty easy. So our last step here is to sub this information into the equation for the straight line, which is just y minus b equals mx minus a, and we're using the point 6,1 because that is the point that cuts the line. So y minus 1 equals 1x minus 6, which is equal to y 1 times x is x, and then 1 times that is negative 6 plus 1. So y is equal to x minus 5. Right, so to get your 3 marks there, you have 1 mark for working out the midpoint, 1 mark, 1 mark for knowing to get the perpendicular gradient, and 1 mark for putting the equation in the right form of y equals mx plus c. Alright, perfect. So now we're told the equation L2, the perpendicular bisector of PR, is 3y plus x equals 25. Calculate the coordinate of point C, the point of intersection of L1 and L2. Right, so this is just going to be simultaneous equations. Whenever you see points of intersection, you always know it's going to be simultaneous equations. So we've got our y equals x minus 5, so we'll write that down. Okay, y equals x minus 5, and then we have this new information that is 3y plus x equals 25. So basically you want to get these two equations in the same form so you can simplify them. So some people prefer it to different ways. For this example, I'll move all the letters to the left and keep all the numbers on the right to simplify it. So that becomes y minus x equals minus 5, and this becomes 3y plus x equals 25. Okay, and go back. And what I'm going to do here, so this is still equation 1, this is still equation 2. I'm going to add equation 1 and equation 2 and see what this gets us. All right, over here. So 3y add y is 4y, x plus minus x is 0, and 25 plus 5 equals 20. So now we can simplify down for y. So 20 divided by 4 is just 5. Okay, so the next thing we need to do is substitute this value of y back into one of our equations to give us a value for x. So we'll substitute it back into this one. Okay, so we'll do 5 minus x equals negative 5. So now we could get negative x equals negative 10, which is the same as saying x equals 10. So now we have a y coordinate and now we have an x coordinate. So what we need to do is to make sure we state the points of intersection. So I'm going to put it here. Point of intersection C is 10, 5. And to get your full marks there, it's going to be 1 for the x coordinate and 1 for the y coordinate.